Physical Sciences Lesson 21. Topic: Physical and Chemical Change. Turn to Lesson 21 in the Learner's Workbook. This lesson includes an individual activity with baseline assessment. Integration. Some aspects of Lessons 15 to 20 integrate with concepts in this lesson. The knowledge and skills you gained in Lessons 15 to 20 will inform and support the new learning you do today so that you have a deeper understanding of chemical systems. Prior knowledge. You have prior knowledge of some aspects of the concepts in this lesson from work done in Lessons 15 to 20 and in Grade 9 Physical Science. The new learning you do today will enhance and extend what you already know about physical and chemical change. Lesson overview. In this lesson you will explore physical versus chemical change, understand the conservation of mass and energy during chemical change, learn about microscopic interpretation of macroscopic changes, know about the formation of metal oxides.
Hi and welcome. This is lesson number 21 in Physical Sciences Grade 10. Tinyiko Kosa welcoming you.
And it's Peter Glover saying hi, and it's good to have you in the driving seat.
Yeah. And now today we're going to talk about chemical change. But we can't talk about chemical change without talking about physical change.
What's the distinction?
Now and that is the reason why we have to bring the two together, because we need to know exactly what is the difference between them. Now let's just have a look at the statements here that bring out that difference. Right, so here we have got physical change. We're explaining what physical change is there. Now physical change involves the change in the physical state of a substance.
In other words, like going from a solid to a liquid.
Yes, going from a solid to liquid, but still the substance keeps its own characteristic, its properties. We're still having the same substance. The only change that occurred is that it moved from one state to another, solid to liquid or liquid to solid. Sometimes we do have a situation where things move from solid to vapor, but you still have the same substance. Now then, what will be chemical change? Chemical change in itself is a process, and here we've got substances changing into other substances.
Okay.
Now
so it's not just like water, snow melting.
Yeah.
It's like water perhaps changing into being changed into what, hydrogen plus oxygen,
something else. Yes. And what the result is has got nothing in common with what you started with. So everything has changed chemically. So now if we were to maybe give those examples, or maybe talk further around the physical change and the factors that affect that or that causes that. With physical change, we see that they normally would depend on the temperature and the pressure of the substances.
Okay. That idea, you say it depends on the temperature. So in other words, if we have solid water, ice, we raise the temperature and it becomes liquid water. Raise the temperature and it becomes vapor.
Water
steam,
in the gaseous form.
Something like that.
Yes.
Okay.
So all this will be physical changes. We still have water, but we have it in different forms.
Physical form.
We still have the water with its own characteristics, with its own properties, but in different forms. So that would be a physical change.
Okay.
Depends on pressure and temperature. Now here it's exactly what we're talking about, that with water, normally at 25 degrees Celsius, it's liquid water that we use every day. And we know that this water, it's solid at 0 degrees Celsius, but it is still water. And it becomes a gas when it is, of course, depending on your level above sea, above the sea, this may change. But more or less at 100 degrees Celsius, we would have water in the gaseous form.
Okay.
Still have water. But then let's now begin to talk about what chemical change is and how does it happen. Now we know that chemical change is a process whereby we start with something and we end up with something completely different from what we started with. So this process, although it is accompanied by physical changes, the chemicals formed during the process are different. So new substances are formed. It's not a situation like the water where we started with solid water, then we moved to liquid water, then moved to gaseous water.
But it was always water.
It was always water. The physical change may be part of a chemical change, but what makes chemical change different from a physical change or physical transformation, whatever, is that with chemical change, you end up with a new substance altogether. Okay. Now we're going to give an example here of the reaction that happens when we break up a water molecule.
And we don't have to worry about how we do it, but it can be done.
It can be done.
Yeah.
At this moment, don't worry about it. We'll talk about that maybe at later grades. Now let's look at the water molecule and how we break it up. There is a water molecule. That's a symbol we use to represent it in a liquid form, and what we do actually, we just pass some energy in the form of
electrical energy. Sure.
Yes, and when that is done, what happens is that we've got hydrogen gas forming and oxygen gas forming. Okay. Now there are two things here that we need to look at carefully. We said a chemical change is accompanied by physical change. Now what is that physical change? We started with water as a liquid. This L here says water in the liquid form. But when we form our products, we've got hydrogen. Hydrogen is in no way carrying the same properties as H2O.
Okay. Quite different.
Quite different. But then we have it in the form of gas, but we started with something in the form of liquid. So there has been a physical change.
Yeah, but it's the chemical change which is important here.
What is important here is the chemical change. Instead of us still having water there, we now have hydrogen gas. It has got completely different properties compared to that. In the same way, there is oxygen formed. It is a gas completely different in terms of its properties compared to where it comes from, the water molecule. Secondly, we can look at the formation of sodium chloride, and I picked this one up because we need to understand clearly what is happening here. We know sodium chloride, it's what we call table salt. So this is something that we use almost daily in our homes. But let's see where it comes from. We have got sodium.
And we know that's a metal.
A highly reactive metal.
Right, very reactive.
It can actually cause a lot of damage to your skin, to yourself as a human being. So we're starting with something that we can say dangerous. It is dangerous. It is very reactive.
I just wanted to ask a question or make the point. We were talking about sodium in the last lesson.
Yes.
And we were saying that it can lose its outer electron quite easily. And perhaps this is the point for us to start noting and remembering that in chemical reactions, very often it's the electrons that are involved
and causing things to happen,
and leaving one thing and joining another thing and so on. But it's the electrons that matter. And you said that sodium is a very reactive metal.
A very reactive metal.
That relates.
Remember to its position in the periodic table, and we said those metals are so ready.
And they lose that electron easily.
Yeah.
That is a measure of its reactivity.
And that is the ionization energy that we've been talking about.
It
links up to that.
Links up to ionization energy. Wonderful. I love it when a plan comes together.
Yeah. And now, thus, a highly reactive metal, it reacts very explosively.
Right.
chlorine, a poisonous gas, right?
Which means it's reactive.
It's very reactive.
Yes.
And now the physical change happened, gas here, and we're ending up with something solid. So there has been a physical change.
Yeah.
But then look at this. We have sodium solid, chlorine a gas. They react together. They give us something solid, and we call it sodium chloride. And we love this. We season our food with this thing here. But we're coming from something poisonous. We're coming from something highly explosive, which is sodium.
A poison,
highly explosive,
a very corrosive thing, and we put them together.
We've got something that we can use in our homes.
Not just that we can use, but we can't do without it.
We can't do without.
And in fact, do you know, I found out something the other day. The word salary.
Yeah.
From the Roman times, sal, S-A-L, was salt.
Oh.
Salaries were paid in salt because salt was so valuable. So you didn't get money, you got
given
salt
as your
That's
wages.
how important it was. Yeah.
So,
we should try that today.
So this, so this now signifies what we mean by chemical change.
Chemical change.
We completely change the chemical properties of substances in forming new ones.
Okay.
So there is a nice one, nice illustration there, using this substance here. Thanks, Peter, for that one. Now, here